Okay, so we're going to talk about how to compute lengths when you are using polar coordinates. So there's actually just a nice simple formula for this. So conditions for this are you have some function in terms of theta, so it's going to be r equals some function in terms of theta. It has to have a continuous first derivative on whatever interval. And then when you're tracing your curve, it has to trace the curve exactly once as theta runs from your interval. So it can't like be overlapping in parts, right? It has to be like a real function. But anyways, if all of those conditions hold, then you have this nice simple formula. So L goes from A to B, and then you take the square root of r squared plus dr d theta squared d theta. So it's a pretty straightforward process to compute this. So I just have one example here just to kind of run through it with you. So I want to find the length of the spiral from 0 to pi, and my function is e to the theta over the square root of 2. So I need to use this formula. So I have r squared plus dr d theta squared. Okay, so this is going to be the function, and this is going to be the derivative of the function. And in this case, so if I try to take my dr d theta, this is a nice straightforward derivative, right? So the derivative of e to the theta is still just e to the theta. So this is just going to be e to the theta over 2. Okay, so if I go and I plug everything in, so I go from 0 to 2 pi. So this is going to be e to the theta over the square root of 2 squared. And then this will be the same thing, square root of 2 over 2 squared d theta. Okay, so let's make a little space. And so if I go ahead and I square everything, so I'm going to get e to the 2 theta over 2 plus e to the 2 theta over 2. And so if I add these together, I will get, what is that? 2e to the 2 theta over 2. And that's nice because now that really simplifies our integral and our ability to take the square root. So obviously the 2's will cancel out, and so then I am just left with the square root of e to the 2 theta. And if that confuses you, you can now rethink of that as e to the 2 theta to the 1/2. And so then you can see, right, that you can just multiply 2 theta times 1/2. And so I need some space. So this will just become e to the theta, so awesome, nice, easy integral. And so then I just need to evaluate this from 0 to pi. And so I get e to the pi minus e to the 1, e to the 0 will just be 1. So this becomes e to the pi over 1. So it's a nice straightforward formula where you just kind of plug all your pieces in, and then, you know, we'll work out the algebra to get something that you can actually integrate. So I'm going to leave it at that, and I will talk to you guys in another video. Bye.